Hello everybody, thanks for joining. Put on your headphones so you can hear me a bit better. Okay, I understand everybody can hear me, so let's get started. Thanks for joining my session. We're going to talk about MLOps, or how to productionize your machine learning models. I'm here for the 6th time already in a row, so some people might think, hey, this is a familiar face, so great to be back here in London. A little bit about myself is I was trained usually as a data scientist, but I've moved on a bit towards data architecture and machine learning engineering, those kind of topics. So I basically run my own consultancy company to advise organizations to how to do that. And you can find me, on LinkedIn. I'm happy to connect. And I also write a couple of articles and books, etc., blog posts. So you can also look into those. Right, machine learning in production. It's not so easy as you might think it is, right? Because I want to start with a famous diagram already in 2015 written by some people at Google that basically said, yeah, anybody can write a machine learning model, right? You can all just open up a notebook, play around a bit with the cool Python libraries that we have currently nowadays, and voila, you have a machine learning model. But yeah, that's basically only where it starts, right? If you run this in an enterprise organization, in a large, big organization, a lot of things are necessary to put that into production. So the little notebook that you just wrote, when you're a data scientist and you create all your skills to produce some machine learning model that forecasts something, that's only the small black box there of ML code that you see in the center of this whole landscape. And this diagram only shows you that MLOps, putting machine learning software in production, can be quite a challenge actually. But luckily, there's a lot of tools for that. And well, look around you here, right? In the conference, there's a huge number of vendors and open source companies and products and frameworks, etc., that help you doing this. And this is a screenshot from the AI Infrastructure Alliance, an organization that tries to help you a bit with this kind of tool selection. And they made a great overview of these kind of tool sets. But this is only the list of tools starting with the letter A. So you can imagine that this list is 26 times this long or so. And yeah, then you have a nice overview, right, of all your tooling. And also maybe you experience that a bit when you're walking around in this conference. There's always the latest and greatest database or data processing framework or workflow orchestration tool, and that can be a bit difficult to get your head around. So I also experience this a lot with organizations that I work for, and I try to approach this problem from basically 3 different viewpoints. First, it's about the culture of the company and about the teams that you have at the company. Second, the architecture, that's very, very important. And then thirdly, actually maybe last, not the most important, is the tools itself, and the tool selection and the choices that you can make. So I want to guide you a bit through these 3 steps on a high level, but we only have 30 minutes, so let's see where we get. Starting with MLOps. MLOps is not a tool. It's also not a tool set. It's a paradigm, a mindset, a way of working, a culture almost. Actually, MLOps is DevOps for machine learning. So the principles and practices that we learned 10 years ago, I guess, something like that, when DevOps was introduced, agile teams working together in a multidisciplinary way to gain trust and speed in the organization, breaking down the silos of development and operations, that's extended in MLOps to data science. So this Venn diagram, and I must include a Venn diagram, of course, in all my slides, because else my presentation is a failure. Anyway, captures this a bit. We have Dev and Ops, that's DevOps, and we add some other things in the mix, machine learning with data scientists, and this nice combination of practices gives you the MLOps paradigm, basically. Multidisciplinary teams are also very important. So it's not only thinking about how toolings cooperate, but also what you should realize is if you're putting machine learning models in production is how people cooperate. So again, MLOps is not about tooling per se, but it's more about, hey, how do I make sure that my data scientist who just created this great model in his notebook somewhere is able to productionize it and gives the right value to the business customers. There's a few new roles I think that are being introduced, and you hear them now since 1 or 2 years or so in a common way. For example, the machine learning engineer, an engineer that sits a bit in between the data and the dev engineer and a data scientist. He's responsible for integrating the model in the existing architecture, serving the model in production, so making sure that the model runs somewhere where actually the predictions can be acquired. Maybe deploying the model as well, but it's also a bit of responsibility for a dev engineer. So you see that there's quite adding the data science to the mix doesn't make it always easier. On the other side, one of my mottos is always, don't make things too complicated, keep it simple, because if you just realize that these roles are what you need, you don't have to have 5 different people that execute this, right? You can combine roles, of course. If you have a great software engineer already in your team, I'm pretty sure he can go fulfill the role of a machine learning engineer with, a few days of training or so. If you have a data scientist, he may also be available to fulfill the role of data engineer and have him being responsible for the ETL process, ELT process, etc., to get the features for his model. So the only thing that matters is that you recognize this and that you recognize the roles that are necessary to do this, and that you have the right people in your multidisciplinary team available that are able to execute this. Right, so that's a bit about my ideas about the culture and the teams that you need for machine learning in production. What about architecture? Before we actually get to the tooling, I've seen many great architecture diagrams, usually very complicated, with all kinds of toolings and arrows and etc. Running around. So I tried to do is basically simplify that again and get to a sort of a reference architecture that is applicable in all of the cases, all of the use cases where you apply machine learning. And yeah, you can tell me if I succeeded or not, but so far what I will present fits these kind of use cases all the time. And from there, if you understand this architecture, you can then make decisions about, hey, what tooling do I need for this? Do I need to replace something? Do I need to buy something, etc., etc. So starting with the basics, we do it for the business, right? We do it for a use case. We have usually an app running in production. It can be a real-time app, it can be a business process that is batch-driven, doesn't really matter, but that needs to have some kind of a forecast, some kind of predictions from a machine learning model. So we need to put something in the middle here, the model scoring component, whatever it is. It's usually an API that you call, right? But it can even be a query to a database that retrieves a forecast, a prediction for something. Anyway, there needs to be a component that gives you these forecasts. We're talking about machine learning, but in a lot of ways you can actually see this model that we have there, this model scoring, also something simple, right? If I would have a model that forecasts what my customers are interested in, like in a retail organization. I have a web shop and I want to forecast the next purchase for this customer, so I can present it in a nice banner on the screen, so he might click it and also purchase that, for example. Yeah, my model could just be, I will forecast whatever the previous customer has bought. That's a model, right? It doesn't make any sense, maybe, but it is, a query that does something at least. So don't think about models being like super complex, super advanced things. They are just components that run a small query or a small API call that retrieve a number as a forecast. If the number is higher than a certain threshold, you show a banner. If the number is lower than a certain threshold, you, well, maybe like in finance, you block a transaction or something like that. So don't overcomplicate things too much in that sense and think about the models in that way. But of course, you have data scientists and they want to have something more advanced. They want to, train a model. So next component that comes in our architecture layer is some kind of a model training component. We need to train a model that produces an artifact, and we call it a machine learning model, that again then is loaded into the API, into the model scoring component that we already created. That model needs to be trained on something, needs to be trained on data, right? We call this data, we call them features. So feature data needs to be stored somewhere, and the place that we store this data is a feature store. Now what are those features, what are they stored, and why is this called a feature store, not just a database or so? Well, because these features are usually some form of calculation or aggregation of your historical data in the past. You gather data based on, for example, the average number of clicks on something, or the number of transactions that somebody made, or any kind of data that is gathered in a historical way, but needs to be quickly accessible to your machine learning models, and also maybe to your API itself. Because if a customer goes into the app and needs to have a prediction, you also need to have that historical data right there available for him to actually score the model. So this feature store is quite important, and this is actually a new component. I'll talk a little bit about it later. You have to think about this a bit, how you want to organize this. I didn't tell you about the model registry actually yet. Basically just a file, a place can be a file store or so, something to store your models there. And the features will not magically appear, of course. What I said, they will probably come from your API that runs, your app that runs, but you need to be gathered in some form of feature engineering process. This can be real time or batch, you can store it temporarily, it doesn't really matter, as long as you recognize that you have some actual data, like the actual clicks from a customer, the actual actions that somebody makes in the app. Gather them as actual data and then transform it into features to be stored in your feature store. Now then we have actually the most important components of your machine learning architecture ready. All of the other reference architectures or architecture in, for example, AWS, Azure, etc., or the tools like Databricks or so, follow this pattern. So if you understand this and you see another solution architecture or something else for machine learning, I'm pretty sure that you can recognize all of these components. Of course, they will have their own flavor. The Databricks will put their own tools in there, and Microsoft will put their Azure components in there. But this is the purposes that they serve. A few important other things to realize is that you have to do some kind of logging and capture the metrics and the logs for basically what you're doing. Because at some moment, somebody would want to know how accurate are your predictions. And don't you have data drift? Is your model not diverting from how you trained it to be? And but what about your forecasts? Are they not suddenly producing all kinds of strange values? So good practice is to basically log everything there in an application, in a logging component, and visualize it in a dashboard. And finally, since we're running in an enterprise, we're running in a professional organization, all of that software that is running somewhere and all of these pipelines and all of these infrastructure needs to be released to your production environment. So you have to have some kind of CI/CD pipeline, a build pipeline and deployment pipeline usually, that professionally and securely and robustly deploys your software and your infrastructure and maybe even your data to your production environment. So, this might seem pretty complicated, and this is maybe a lot to take in, but it gives you maybe the basics to work with. And if you're now going to check the tooling for this, And I'm going to skip this slide for now. I want to focus on 3 dimensions basically for tool selection. For only each of these components that you have, you basically should ask yourself 3 important questions. What do I want? What fits my organization? What do I want with my tooling? First dimension is the old traditional one, buy versus build. What fits your organization? Do you want to buy software which is readily available, which will cost you some money, basically? You have to pay a license fee. Or do you want to build your own products, maybe with the help of open source, but you have to maintain it. Everything has its pros and cons, of course. The second one is a bit more specific for machine learning, and that's a debate that's now, a question that's now very important. Do you want to use AutoML models, or do you want to build your own custom models, build and train your own custom models? It depends again on your team and on your culture of your company. If you have like 100 data scientists available with all PhD degrees, and they are, super advanced in all the Python frameworks and all the machine learning tools that you have, yeah, go ahead and train your own models and productionize them. But if you are in a big company and you only have a few data scientists available and you just get started, why not just pick a few models that are readily available out of the box and use them and maybe tailor them a bit, fine-tune them a bit, and use what is already available, because you can maybe launch into production faster. And there's also a gray area, because a few years ago, all the machine learning models had to be trained by yourself. But now, if a customer would say to me, "Hey, I have a data scientist, and he wants to train his own." For example, his own sentiment analysis model based on text. And we have all this email from the company, or we have this customer interaction on Twitter, and we want to detect if it's negative or positive sentiment. Yeah, I don't know. I'm not sure if I would advise it, because those models are available, right? You can just get a text analysis model that gives you a pretty good sentiment analysis score from Google or Microsoft or open source, and it will probably do the job. Maybe not as good as training your own custom model, but there's a trade-off between how fast you can release something and how much you want to invest. And good is good enough, right? That's the whole deal here. Another important topic on this area, AutoML versus custom models, is when you will be launching generative AI models. It's a very hot topic nowadays. And generative AI, let's face it, in reality, is an AutoML model. At least that's how you can see it. It's a model that has been pre-trained already by one of the big companies, Microsoft, Meta, OpenAI, and you can fine-tune it a bit or do a bit of prompt engineering to get the predictions that you want from it. Yes, you could also train your own large language model or your own graphical analysis model, but do you really need that? And is it worth the effort? That's something you should ask yourself. And finally, another traditional architecture discussion, I think, but it's important to realize that, again, that's still important. Do you want to have an all-in solution that does everything for you? You just install the whole tool set and it gives you the whole platform, gives you a machine learning platform? Or do you want to have point solutions that maybe do one thing extremely well, but the other ones not so well or not at all? If I would say okay, hey, I'm going to step up to let's say Amazon. Amazon has the AWS platform, it's basically all the tools available for me that I need. But do they have the best tool available to train my machine learning models or to store my features in as a feature store? Well, maybe not, but is it for me then worthwhile to actually move to a vendor or a new product that steps out of this platform? Yeah, that's a difficult discussion, and it leads a bit back again to the buy versus build discussion, similar discussions, but something you have to realize. If you score all of these possible tools on these 3 dimensions, I think you get a pretty good overview of where you're heading to with your organization. Luckily, it doesn't have to be so complicated. You can start small, keep it simple. All of these components that I showed you, maybe with 1 or 2 exceptions, can be done with tools that you already have available in your organization. right? Your machine learning environment, the tool that you use to write software in, can be a simple notebook or the laptop of a data scientist. Only when you get more advanced, you need a professional IDE, etc., etc. The tools that you use to run your batch jobs, and basically a lot of things that we do in machine learning is batch driven, right? The model training, sometimes also model scoring, feature engineering, maybe feature production deployment, etc. There's a lot of batch jobs there. You can go for a workflow orchestration engine, like Airflow, etc., etc. But then again, it's another tool that you have to manage and buy, etc. Or you can just start small with batch scripts, with something that runs on your local machine, right? Why not try that first and see where you end up, and only after a certain while, when you reach a certain limit and you want to step up, you scale up to a professional tool. It also goes for the feature store. Features can be stored in a simple database. It goes for model serving and storing. If you want to professionally store and version and publish your models, you probably need something like a model registry application. And you can buy one or you can build one yourself. But you can just start by storing your models, which are basically files. Let's face it, they're files that you have exported from your model training algorithm to a file store that contains version information. So you can go back to the previous version, etc. That's probably all you need in the beginning. And for data processing the same. A lot of fancy tooling is available for big data analysis and big data processing, like Spark and Flink and all other great tools. But you can start small with maybe Pandas data frame or just some plain Python code. I want to highlight two specific tools that I already mentioned before, because they are, I think, the most specific for machine learning at this moment, and also the newest tools on the block a bit. Starting with Feature Store, something that we, at least I hadn't heard of like 3 years ago or so it's still relatively new. I already explained a bit what it is. It's a store for storing your features. Why do you need a specific database for this and not just, you can start with a small database, as I just said, but why, if you scale up, why would you need a specialized database for this? Well, usually because your features are used in two ways. Your features need to be used in offline mode, and that means that when you're training a model, you need to get all the historical features from all of your customers or your entire landscape of data. And you need to be able to get that from the database and to process it. But at the same time, your database, your feature store, also need to be able to really quickly, like in maybe 100 milliseconds or less, get the features for one customer in real time, the latest features. Because that's what you need when you score the model. And we call it online serving. So this combination of online and offline serving is basically very difficult for databases to accomplish. Even if the NoSQL database, etc., that we have now, it is very difficult to do that with one database. You would have to build maybe a caching layer on top of that, and then keep it in sync, etc. Well, okay, good luck, you can do it yourself, but there's also dedicated software for this, and that's the feature store that you can get. And some examples here, Feast is open source, Hopsworks is a really interesting product, H2O has one, Google Vertex AI is a feature store, and there's plenty of other ones. So they're all pretty good tools for doing this. And finally, workflow orchestration. Nothing new. Workflows and batch jobs have existed for a long time, but they have also specialized a bit in the direction of machine learning. So tools like Kubeflow and MLflow now exist to make it easy for you to orchestrate your workflows in your machine learning architecture. So they are there to help you do feature engineering, model scoring, but also tracking your experiments when you're actually training your models. So investing and selecting a proper workflow orchestration tool is a good idea, basically. Well, finally, what about generative AI? because yeah, we're here, of course, because of generative AI. That's why this conference is so booming, I think, which is a good thing. We're just getting started with this, right? It's only been maybe a year or so since we have this boost in ChatGPT, and now others are following, like Palm, Midjourney, etc. So we have large language models, we have generative image models, etc. What I already mentioned, treat them for now, for maybe 95 of the organizations, as an AutoML model. You could create your own vector database as a specialized feature store, and you could train your own large language models, but the question is, do you want to do that? Because is it worth the effort or not? There's already plenty of tools available that help you to fine-tune and prompt these models. So that's where probably your effort should go when you're going to use this. And then they fit the architecture nicely, because they are just an AutoML model that needs some kind of features, and that needs a little bit of prompt engineering, feature engineering basically, to get the right details from them. So to wrap it up, some takeaways on your MLOps journey. There is no silver bullet. That's an old saying from I think 1985 or so. One of the classics in software architecture. Still true. There's not a tool that magically solves all your problems. Doing machine learning in production can be quite difficult, can be hard, but yeah, that goes maybe for a lot of other software as well. If you want to do it professionally and you want to get to a certain maturity level. But luckily you can start small and scale up later. You can apply the DevOps principles, and actually then you have MLOps. So don't see MLOps as a tool, but see it as a practice, how to build your teams and how to introduce a culture of cooperation and doing the right business processes there. And I explained the reference architecture for machine learning. Hope that helps you a bit. And finally, I told you a bit about the tool selection that you could use based on these 3 dimensions for all your tooling needs. Some further readings if you're interested. MLOps is actually becoming more mature already. So there's courses for that. There's websites that help you on this way. There's books, etc. So I will leave this on the screen, because you can also download the slides later and click on them. These are my favorite tools for this. And one of them is actually a book that I wrote myself. So that's a bit of self-promotion, but that helps you a bit further, hopefully. And then I would like to thank you for your attention. And I think we have some room for some questions, right? 2 minutes, okay. So if you have a question, then raise your hand. I have to put this on, also I don't hit it.
Can you just speak to this? Yeah.
Hello, hi, can you hear me okay?
Yes, I can hear you.
Yeah, so thanks a lot for the talk, really interesting and informative. A quick question on the reference architecture you've proposed. How long do you think, given that you'll be going with open source and with some custom programming to stitch everything together, how long would it take for you to get from the starting point where you have nothing on board to a reference architecture which you proposed, in your experience?
Yeah, it depends on your engineers, how quick they are. But I would say maybe 1 or 2 months or so. That's what you need to make this into an integrated solution. And the problem is indeed the integration, right? I mean, if you have one engineer that does some things on his laptop or so, it will work. But then you can say it works on my machine, right? But there's something else than putting it in production.
Cool, thanks a lot. And one follow-up question on this. Usually one of the things which we see with machine learning is you can't really test it on staging environments, right? You would have to release it into production and test it over there while making sure none of your production traffic is impacted.
Yeah.
So what would you propose as best practices around that? Yeah,
that's a really good question actually. Yeah, I mentioned already a bit that it's very important to do monitoring on this, because in a way it's always a gamble if you train a new model and you put it in production. It's always, okay, what would the model produce? Because it's it's fuzzy logic, right? It's non-deterministic. So you never know what your model will actually produce as a result. But that's if you want to be sure, then there's no other way than maybe getting, for example, a sample of your production data in your pre-production environment, your testing environment basically, and train your model there and see what the outcomes are there. Because else it will be too risky maybe for you. So in many of the organizations that I work for, that's also the practice that people are following. Yes, they run a model in production, but before actually launching the model in production, they actually test it. They see what the effects is of releasing this model to a pre-production environment where this is available. And you can use the traditional, I would say, practices for testing software in production as well, like A/B testing, for example, and canary releases, etc. Being able to quickly go back to a previous version. Those blue-green releases, etc. Those are also an option, of course, for you. Thanks. Okay. If there's any further questions, else, thank you very much. Thank you. Right.